I'd like to introduce our next speaker, Dan Barstow. He is the education manager with the Center for the Advancement of Science and Space, CASIS. And Dan is a former president of the Challenger Center for Space Science Education, the national headquarters, and he's a longtime advocate for space science education. I also want to say that working with Dan and Ken Shields and Diane at CASIS has been wonderful for SSEP. As a national partner, CASIS provides a significant amount of funding to close budget shortfalls. And the way that this works is that if a community wants to come aboard, SSEP is not cheap. It's $24,000 for us to do this program, full cost recovery, as a nonprofit, because we have to pay for launch and return to Earth services and support all of the national side of a program for a community. And we work to help communities that don't have funding find the funders out there, because we don't want to deny a community's participation in this program because of funding. So we at the center work very hard to identify funders. And what happens is that there is a deadline that hits when we've got to have letters of commitment of funding in advance of program start. We can't delay that anymore. And it may very well be that we still have a shortfall of a few $1,000s that we can't find anywhere. And that's when we use the CASIS discretionary money to close those budget shortfalls. So CASIS is directly responsible for tens of thousands of students participating in this program because we were able to close the budget shortfalls for those communities. And Dan, please thank everybody on the CASIS team for doing this. It's just been so joyful working with CASIS on SSEP. So with that, let me introduce Dan Barstow.
Well, thanks, Jeff, for those appreciative words, and I also want to thank you for the great work that you do leading this program. You know, at first I thought, boy, this is a tough act to follow. You know, Don's an astronaut, and I'm getting up to talk. That's a tough act, but no. The tough act to follow are these students who've done these amazing presentations. So a big applause for all of you for your great work. Well, I'm the education manager for the International Space Station, and that's quite a treat because I get to work with all of you and a number of other projects that we do. The space station is actually a remarkable spacecraft. It's taken about 15 years to assemble it. It's taken many countries, many people. It is an experimental platform par excellence. You all, or many of you have done experiments there or are about to do experiments. It's a great asset for research. Now, Jeff asked me to tell you a little bit about the latest things going on in the space station, and I thought instead of telling you about it, I'd like to take you to the space station so you can experience it yourself. Now, how many of you want to be astronauts? Okay, I know you do. All right? Well, Don gave a very clear message. It only takes two things to be an astronaut. The first is your heart. You have to want to do this deeply and strongly. And the second part is your brain. You have to work hard, learn, think, get all A's or maybe one B, and proceed through this path until you become an astronaut. Well, you're now Space Station Explorers. That's the name of the program for all of the different programs we have. We reach approximately 400,000 students a year. We're growing that. We're all called Space Station Explorers, so you're now a Space Station Explorer. Now, you're going to have a simulation here, just like the astronauts do a simulation. And let's go ahead and check in with Mission Control. They're all saying, go, 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 ready to launch. You keep on going. It's 8.5 minutes, as Don mentioned. It's a remarkably short time, but it's the most thrilling experience of your life as you go and you approach your target. There's the space station. So now you go closer and closer. Your job is to dock gently, gently, and then you open the door. And are you ready? You're floating. You're inside the International Space Station. You have to be very careful. Don't bump into any of those switches. You see that blue bar up above? Grab it with your hand. That stops you moving. There's one down below your feet. Hook your feet there. That holds your feet so you can be safe and in control there. Let's go say hello to some of our crewmates as they welcome us. Hi, thank you so much. Have some meals up there. Great food in your little squeeze tubes and cans and so on. If it gets too crowded at the table, you can sit on the ceiling or underneath the table. Make sure you do your exercise 2.5 hours a day, the treadmill, the bicycle, and so on. And then at the end of the day, get your rest. Sleeping, strapped down so you don't float away into the galley. And now, your next day, your full day in space, you're going to do a little bit of work here. Going to do a little bit of exploring. That is inside the Destiny Lab. Look how complex that is. So many different experiments going on. It just gets more and more and more full as you fill up with different things that the students and others have designed. Now, some of the experiments have to do with plants, and you've all demonstrated some of those, making the lettuce grow, giving it the right kind of light, and then tasting it. Don asked about the taste. Apparently, the taste of the lettuce is bitter because it's reacting to the stress of space. You move over to the glove box, a great place not just to mix the tube, but to do other kinds of experiments that need to be self-contained. Notice the camera that you need to set to photograph the experiment as it happens. You also test your body. Your eye adapts. The astronauts often report their vision gets harder because the inside of your eye, the vitreous humor, isn't used to the weightless, and so it's harder to focus. And you need your eyes because you need to observe space, Earth. That's one of your tasks there. This, and if we could cue up the Florida movie, this is flying over Florida at exactly the same speed. If you could start that, there you go. That's exactly the same speed that you fly at 17,500 miles an hour. If you want to photograph Lake Okeechobee in the middle there, you have to quickly grab your camera, take the picture. You have about 30 seconds to do that. Now let's go back to the slides. You might capture the smoke of the fires that have been in Florida this past week, or an erupting volcano, or glaciers to monitor climate change, one of the clearest metrics of this warming Earth. Now, while you're there, you have an important task. Go over to the cupola, look out, and your job now is to grab that SpaceX 11 that just arriving here, with the experiments that the students have designed. So it gets closer and closer. You control your robotic arm to reach out, and the end of that hooks into the SpaceX. You grab it, you pull it in, and then open up and extract the experiments that have just arrived. Now, doing a little analysis before this presentation today, here's a very interesting fact. There are 28 student experiments on there. There are 6 scientist experiments. Think about that for a moment. 28 student experiments, many of them thanks to all of you. 6 of them are the science experiments. It's this incredible combination. So what are all those experiments that have just arrived on June 2nd? Some of them are student experiments that go into these labs, your mixing sticks and so on. There are a few other student experiments. The Bell Middle School in Colorado is doing worm composting to see how the worms behave in space. There's another group in Colorado testing biofuels and so on. But another experiment that has just arrived is a really interesting one dealing with rodents and how they behave in space. The good news is, if you're a rodent, that the experiment lab now enables you to come back to Earth. That's really good news. That's happening July 3rd is returning after a month in space, the rodents that they've experimented. For the rodents, they've been testing bone density, just like some of you have been experimenting with that. There also are some other science experiments that have just come on board, including experimenting with cardiac stem cells for your heart, strengthening your heart, and some enzyme research. This is colloids that are suspensions inside liquids and how they behave differently in space. All of those are the new experiments that just arrived. Plus, we brought up 1.2 million tomato seeds. We'll bring back those tomato seeds, and then you'll be able to, students around the country or around the world really, will be able to plant them and see how tomato seeds compare with what's grown on space. Now, there are a couple of platforms that have just arrived. The MUSES platform is a pointable camera for looking at Earth. It mounts on the truss structure on the outside. You can see where that arrow points. And now if you could cue up the movie. This is, with this MUSE platform, it points and looks at different angles at Earth, and you're able to see, this is Spain at night. That camera now is a great platform for exploring and learning about Earth. If you look around, look a little north, you see this beautiful aurora circling the Earth. The perspective that you get on all of this is just daunting. Well, now back to the slides. Thank you. And we also have an experiment pointing out into space. The NICER is looking at neutron stars, because just as you can look down at Earth, you can look out in space. You don't have the atmosphere in the way for this kind of detection. Well, it's been an amazing experience, but now we have to bring you back safely to Earth. I promised Jeff that we would bring you safely back. So you go through your checklist. You're going to deorbit by braking impulse, parts of the Soyuz. And by the way, we're still using the Soyuz spacecraft until we get the Orion and the other ones that Don was mentioning earlier functioning in about a year and a half. Then come in, the aerobraking happens as it comes into the atmosphere and the parachute opens. So, bye crewmates, it's been great to be up here with you. Thank you so much. You float over down into the spacecraft. Luca Parmitano is going to set all the switches for you so you can safely return. You disconnect, and then you come screaming in through the atmosphere, buffeting, and all of a sudden you're feeling this, not just gravity, but multiple times the weight of gravity that you're used to. But finally, the parachute opens. But I need to warn you that the landing is still a bit rough. Now, you had your seat form molded around you before you went on your launch. You're in your seat, tall, short, however it is, it fits you. And you need that because, wham! Down you come. The retro rockets fire. It still is a rough landing. And when you get out, don't be the big hero and going up and down saying, yay, I made it. Instead, let them carry you very carefully. By the way, this is Scott Kelly, who is part of another piece of experiment we're doing comparing Scott and his twin brother Mark. One was in space and one was not. The comparison of those, his 300 days in space and his brother's previously was an astronaut but didn't travel at the same time. Comparing them, we see some very interesting things about how their human biomes adapt to space. And of course, all the photographs you took will be great use for kids and for scientists. Because the purpose of the space station is not to give you this mission into space, as thrilling as that is, but because what you're doing contributes to the larger mission of taking care of home planet Earth. Well, a big congratulations to you. You've now completed your first mission to space. And thank you all again for these great experiments that you've been describing. I look forward to hearing the rest of them. Thank you.